What is going on, guys? My name is Hussein, and welcome to another episode of Wireshark Them All. And today we're Wiresharking Postgres database. We're gonna see how it does it look behind the curtain. We're gonna make a connection through from a Node.js client to a Postgres database that I spun up in the cloud. This is using Elephant SQL. It's a very easy service that they're not a sponsor of this channel. It's just literally I like this service. It just literally took me 2 minutes to spin up a Postgres instance so I can do this video. So how about we jump into it, guys? So here's what I'm gonna do. I'm using Node.js Postgres, and I made a video on how to connect to a Postgres database from a Node.js client. Check out this video if you're interested. But what we're gonna do here is literally I have already established a Postgres database. I created a table called employees and I added some rows, and this client does the following. It connects to the database, right? It issues a query select star from employees, and then once it does, it returns the result and immediately closes the connection. That's what it does, nothing else, right? How about we jump into it and run this client and see what it does, right? So I'm gonna do node, I believe I called it query.js. When I do that, this is what I get. It just prints a beautiful table of whatever is in that cloud database that I created. Rick, Edmond, Hussein, all of those people are employees in this table. So let's look at the Wireshark. For Wireshark, here's exactly what we did right now. These are all the packets. It's not as much as I thought, to be honest, right? And I used a quick filter based on my client IP address and the server IP address. So I just literally pinged the Ruby, whatever the server I got, and I got the IP address and I used it in Wireshark to actually see what happens behind the scenes. How about we actually look at this, guys? First, beautiful 3 requests: syn, synac, ack. Why? We're establishing TCP connection. Postgres uses TCP. No, who knew, right? So we're establishing a TCP connection. So there's no escape of these puppies unless you're doing a TCP fast open, which I talked about on this channel as well. And here's the thing: who's the first person to make a request? It's the client. It says, okay, I'm gonna send you this thing, and here's what it does: send, hey, here's my version protocol. Here's my user. The parameter name is user. I'm gonna send another parameter. Database is this, same database. So this username is this. The database is this, and this is the client encoding. I support UTF-8, right? And you notice that we didn't send the password for some reason, despite it is in the connection string. If I look at this, the password is right there. That's the whole password, right? I don't care. You can take it because I'm going to destroy this instance after this video. But look at that. We don't send the password, and I'm always curious why. The server says, acknowledgement, I got your request, but here's the response. What is the response? It says, okay, I'm going to authenticate you. I found that this username exists. You can access me from this database, from this user, from this client, from this IP address, and just send me the MD5 password hash. Let's go ahead and send it to me. And this is not encrypted. That's why it's very important, guys, to encrypt Postgres connection, pretty much everything. But we're learning here. That's why it's actually a good thing that this is not encrypted, so we can see what's behind the scene. So the server says, okay. The client says, acknowledge. And this now the client says the P, caret P, which is this is my MD5 password, and it's what is 41 character, right? So it's the whole thing is 40 character, and the length of and that's my password hash, MD5. Sure, obviously MD5 is not gonna save us here, right? Because the whole thing is decrypted, it's unencrypted. Server says, yo, acknowledge, and the server says, okay, look at this. Authentication request success. I have been able to authenticate you. And here's a bunch of stuff now, right? The application value, right? What kind of data type we use for integers? What kind of data type we use for dates? What kind of data types you should talk to me in case of super user? There is no super user in this connection because, of course, you're not supposed to be a super user if you're connected through the cloud, right? At least in this connection, right? What's the server version? I'm using Ubuntu. Oh, look at this, 11.8. Postgres 11.8. I'm running on Ubuntu. I don't know if this is 11.8 Ubuntu or Postgres, because there is a Postgres 11. That's interesting. I didn't see any version of Postgres here. But yeah, it just sends a bunch of things, and here's the last thing. I'm ready to receive your queries, baby. Send me those queries. All right. The client says, yo, I acknowledge your thing. I got it, right? And that's the thing, man. If we can just delay a little bit and kind of just, I guess no, we cannot delay the ACK in this case, because we don't know when the client is going to issue the query. But yeah, what is this now? Select star from employees. We are finished from this step. That step was literally, that one line of code was all those, I guess, up to here, up to this packet. And here is the query. That's why the caret Q. And we're here now. We're selecting select star from employees, and we just send it as plain text, right? And I wonder if the query is too long, like you do select star in blah 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 blah. That's too long. And I wonder how many packets we're gonna break this thing out. I guess it depends on the TCP window and all that stuff. But yeah, the server says, I acknowledge that I received your query, but I don't have a response for you yet. But this is just an ACK. It says, hey, I received your query. And this is very important for the client to start unblocking and do its async stuff, right? And here's the thing. I love that Wireshark just recognized pretty much everything. Man, I love this stuff, man. This is a toy that I just discovered, and I'm just in love with it. All right, so there's the actual content. It's just the 300 bytes. No, I take it back. 237 is the actual content. 300 bytes is the whole with the garbage of the TCP stack. Look at that, all the fields. This is rec. This is whatever, all the content, right? Data raw. That's the data. Look at that. These are actual numbers. The content is numbers, and they are converted into strings, I guess, right? To ASCII string or UTF-8 strings. Awesome. So the client will say, yo, I acknowledge your result. And then what is X? That's a termination. It says, yeah, I'm done, son. I'm done. Now we're here, right? Because this is just the client side, right? Now we're here. We're killing the connection. We're killing the connection. The client says, yo, I want to close. And immediately after that, doesn't even wait for an acknowledgement. Jeez, savage client, man. All right, so the client just say, all right, I'm gonna fin ACK you. I'm gonna fin and ACK whatever we had before. So the client just initiate the connection in this case. To me, if it was me, to avoid the TCP wait, I will actually have the server initiate the fin ACK so that the client end up in the TCP wait. So that's just like you don't have all this garbage TCP wait stacks. I might be wrong. There might be not possible in this case, but yeah, I would, if it was me, if I designed the protocol, I would flip this. Yeah, since the client is initiating the close in this case, right? We can actually respond with a fin ACK from the server. So we wait a little bit from the client. But this, it really depends on how the client is designed, because in this case the client PG, I think Brian, I forgot his last name, sorry Brian, but yeah, he's the one who built this Postgres Node.js library. So it depends on how the client is built as well. So yeah, fin ACK. The server says acknowledge your fin, and this is my fin, and then I fin the fin, and then we're finny. That's it. We're done. All right, let's clean this thing, and let's throw in a monkey wrench where, I don't know, let's add a bad thing where the correction string is just wrong. If I do this now, I'm going to get an error. This is like a bogus error when things are wrong, and you want bogus errors from the server as much as possible because you don't want the server gives you a hint. Oh, the password is good, but the username is wrong, or the username is good, but the password. Never do this. As a backend engineer, never be as ambiguous as you can to the client. And I understand this is not a good user experience, but leave it. You want, for security reason, be as ambiguous and as not that, what is that ambiguous, the word, not ambiguous, it's like be as confusing as possible. Don't give the hacker or someone clues to what is missing in their request, right? I understand gives you bad user experience, but you need it for security reasons, right? So go back, look at these beautiful things, beautiful, beautiful, beautiful TCP connection, three-way handshake, all that jazz. We talked about three-way handshake. The client says, yo, I minimum version is 3 and minor version is, what is this exactly? Is that, I still don't understand. Is it 3.0 major? Is it, maybe this is the Postgres client version? I don't even know which Postgres I'm using, which version, and it's not really clear, huh? Never mind. Acknowledge, and the server says caret E. That means error, huh? I literally just found out, by the way, guys. And it says, yeah, whatever the message that the server receives, the client just printed it for us, right? It's just like, this is exactly what we got. We got a 2000, it's fatal. And when it's fatal, you gotta close the connection. It says no PGA config for user this. That's the bogus user, and database, blah, blah, blah. So, and, oh, that's not good. Really? We're sending the code? It's not really the code, but tells you like which file of the code. I didn't know that. Even the line number? Oh, come on. That can't be good. I don't know about you, man. I think this is a little bit shady. Okay, so it's an error light. I don't think we should send. Might as well just send the stack trace. Jesus, I don't think this is a good idea. ACK, fine ACK. Who? Okay, we're acknowledging. The client is acknowledging the server, the error, and then the. Oh, look at that. In this case, the server is finning. The server is finning the connection. So it's like fin ACK, and the client will ACK, and then, oh, this is a mess, right? Now we already established closing the connection, but the client, this is a bug to me in the TCP in the client code, right? Because we clearly, the server already established a connection, but we are sending it data, and that's why we really need to. This is one use case of the TCP wait, right? Where it's actually waits for more packets to come to clean things up. Obviously, the client the server will just immediately drop this connection. So we're sending it for nothing. And that probably explains the reset, right? So that's a bug, in my opinion. I think it's a bug in the client code. So it's bug in here in the PG package, right? And basically, the fix could be that if you receive a client error, don't attempt to do a terminate because the server will terminate it for you, apparently. I might be missing something though, but yeah, that explains the resets that we have here, because like, hey, something went out of sync and you started sending me packets while I'm trying to close. Obviously, the client did essentially establish the close. But yeah, anyway, guys, that was like the Postgres, Wiresharking Postgres. I'm gonna see you in the next one. You guys stay awesome. Let's suggest what should I Wireshark next, and I'm gonna see you in the next one, guys. Stay awesome. Goodbye.